Hey, good morning, students. Today's session we are going to discuss about the priority queue and what are all the real-time implementation of the priority queues. So we want to discuss that. So before going to the topic, we have to discuss what is meant by the priority queue and what are all the characteristics of priority queue. And next one is what are all the two different operations for implementing the priority queue. So first one thing is the priority queue. For considering this the priority queue, so it is also it is also called as an abstract data type. So all of you are knowing this. What is meant by the abstract data type? So this data type is mainly used for finding the set of functions with the implementation of a function with some data type. Okay. Okay. So here the priority queue is behaves like the normal queue. So all of you are knowing that the normal queue structure, the queue follows the first in first out formula. There is first in and first out formula. So this is an FIFO. But here we are using the same. But here what way the normal queue and the priority queue that should varies means the priority queue that gives some priority for each and every element. So this is one of the major representation of this the priority queue format. So this is a one here we just consider the element with the highest priority that should be considered for this the priority queue. This is the first one. Another one thing is what are all the characteristics of the priority queue. So priority queue means you just consider the three important points. So each and every element in the priority queues has some priority that should be associated with it. So based on the priority, we need to process, or we need to insert, or we need to swap, or we need to process the information based on their priority. So here, an element with the higher priority will be deleted before the deletion of the lesser priority. Suppose if we are having the same priority queue, if we are in this priority queue, if we are having the same priority, so we just follow the first in first out principle. So first in first out principle. So this is an example for representing that information. Suppose we are taking the elements as 2, 6, 7, 10, 11. So here, suppose the front, there is this process that should represent the highest priority. This is for the lowest priority information. Okay. That's all about the characteristics of priority queue. And so what are all the two types of priority queue? So here we are taking as the ascending order priority queue and descending order priority queue. In the ascending order priority queue, so we just give the top priority for the lowest priority number. That should be a highest, we just give the highest priority for the for processing the information. Suppose it should be in descending order, we just give the highest priority number that should be given as an given as a there is, suppose in the ascending order we just give the highest priority for the lower numbers. Suppose in the descending order we just give the priority for the highest numbers. So these are all the two different types of priority queues are used in our process. So after this and the implementation of the priority queues, the priority queues can be implemented in four ways. Suppose if you are following arrays, linked list, heap data structures, or binary search tree. So already, okay, all of you are knowing that arrays and linked list concepts. So in array, so we just store all the similar information on the same variable. But linked list, that is, we just we just do the insertion and deletion process without considering the adjacent memory and heap data structure. So these are all the four important techniques can be utilized for implementing the priority queue. So we just discuss how we are going to insert and delete an element in an priority queue. Okay, so the next one thing is suppose therefore we are having the two different types of heaps. One is the maximum heap that is called as a max heap. So another one is called as an the min heap. So what is meant by the min heap? So how we are going to discuss? So this is a max heap and this is an min heap. So max heap means what is in here? For this heaping process, the value of the parent node is that should be greater than the the value of the child node. So this is a maximum heap. So min heap means we just consider the minimum value, the heap value of the parent that should be less than children node. So the maximum heap we just consider only the greater the value maybe must be greater than the child node. Here the min heap means the parent node value that should be lesser than this the child node. So these are all the two different types of heaps. So this is an example. This is an example for max heap. This is an example for min heap. So in the max heap, we just consider the highest. We just take the highest number. So 45 is the parent node that should be greater than the child node, that is 30. Here you just consider the 40. So the parent node that should be greater than this the child nodes. For example, min heap, you just consider this node parent node is 5 is less than this the child node 6 and 7. So again 6 is less than 8 and 9. So here 7 is less than 14 and 24. So this is an example for generating the maximum heap and the minimum heap. Okay, so after that, so next one thing is how we are going to insert an element in the heap or deletion in the element in the heap structure. Suppose if we are considering the three structures, so this is an example. Suppose I want to insert an element as 5. So how we are going to do this the insertion process? Okay, so this is one thing. Suppose I just insert it. So we just check whether the root node that should be greater than this in max heap. Okay, so here consider this node 5 is greater than this 3 and 4. Here 4 is here this is a min heap I think there. So you just consider this part, this tree structure part. We just apply the max heap. So we just insert, there is easiest insert element now. So automatically 7 is greater than 5. So we need to swap the element of the given tree structure. So this is one of the example for inserting an element in the heap. So this is one of the example for insertion. That's all about the insertion process. Suppose consider about the deletion process. So consider the tree structure. Suppose I want to delete an element 3 from the given tree section. So automatically it goes to the least part. There is the least possible nodes. Okay, so here 3 and 5 now. So this is the least possible node. So here we just compare. Okay, so here 3 and 5 that should be compared. So if it is greater than that, we just interchange that. So I need to do the interchange process here. So 5 and 3. So now I just remove the entire element 3 from the given tree structure. So I just delete the element from the given tree structure. So finally you got the key P5 tree structure for the process. So 9, 5, 7, 1, 4, 2. Okay, so you just consider. So this is a final key P5 tree representation of the given the priority queue format. Okay, so that's all about the insertion and deletion process. So after this, so what are all the applications of priority queue? So it is mainly used for the Digital's shortest path algorithm and the Prim's algorithm. And third one thing is suppose if we are going to implement the data compression with the Huffman code. So how we are going to do the compressing the data using the Huffman code. And next one is suppose if we want to perform the heap sort. So these are all the applications of the priority queue. After that, suppose the same methodology can be utilized for the operating system, such as the priority scheduling, load balancing, and the interrupt handling. So for this aspect, we just follow this the priority queue mechanism. Okay, so these are all the examples. So suppose if you want to know some real-time example for this the priority queue, you just note it down some priority scheduling of the CPU resources. Another one is how to balance the loads and how to do the interrupt, how to handle the interruption handling. So all the three things are done with the help of this the applications of priority queue. After this, suppose if you are going to do this the implementation of this the priority queue. So what is the and the time complexity, how much it will take for inserting and deleting or finding the element. Suppose the binary heap, you just take it as the insertion process that should take order of log n for the inserting an element. This is the time complexity for removing an element. Suppose if you want to search an element for the particular row, it takes order of 1. So similarly, we just consider the linked listener, it will take order of 1, and removing as well as the searching is taken as order of n. Suppose we may implement the same scenario in the binary search tree, it will take order of log n for insertion and deletion, and peak process take order of 1. So this is the way for these are all the time complexity for inserting and deleting an element in the in the priority queue. Okay, that's all. Thank you.